All right, if you're gearing up for your OCR GCSE in computer science, you already know that algorithms are a huge deal. So in this explainer, we're going to crack the code on section 2.1. We'll cover everything you need to know to absolutely nail that exam. Ready? Let's dive in.
So let's start with a big question. How do you solve, well, any problem? I mean, think about it. It could be something simple like, what am I going to wear today? Or something massive like, I don't know, launching a rocket into space. Turns out, computer science gives us this amazing, step-by-step way of thinking that works for literally any challenge. And that's exactly what we're going to get into today.
Okay, first things first. Before you even dream of writing a line of code, you've got to learn to think like a coder. The official term in your exam spec is computational thinking, but really, it just means learning how to look at a problem and break it down in a way that a computer can actually understand and solve.
So the first big idea in our thinking toolkit is called abstraction. And honestly, you do this all the time without realizing it. You know when you look at a tube map or a metro map, it doesn't show you every single street, every tree, every coffee shop, does it? Nope. It just shows you the important stuff. The stations, the lines, the connections. That is exactly what abstraction is. It's all about ignoring the useless details so you can focus on what's absolutely essential to solve the problem.
Next up, we've got decomposition. This one's a lifesaver. Imagine you were told to build a car. You wouldn't just, try to build the whole thing in one go. That would be insane. You'd build the engine, then you'd work on the body, then the wheels. You break that massive, scary task down into smaller, much more manageable chunks. That's all decomposition is, taking a huge problem and smashing it into little pieces you can actually solve.
And rounding out our big three, we have algorithmic thinking. So you've used abstraction to get rid of the noise, and you've used decomposition to break the problem down. What's next? Well, you need a plan, right? A step-by-step guide. The best way to think about it is like a recipe for a cake. It's a precise set of instructions that, if you follow them exactly, you're guaranteed to get a perfect cake every single time. That recipe? That's your algorithm.
So there you have it, your core thinking toolkit. Abstraction, decomposition, and algorithmic thinking. Simplify the problem, break it into pieces, and then create a step-by-step plan. Get these three down, and I'm telling you, you're already thinking like a programmer.
Okay, so we've got the mindset down. We know how to think. Now, let's talk about the actual tools you're going to use to turn those thoughts into a real solid plan. These are the things you'll definitely see in the exam when they ask you to design or show an algorithm.
Pretty much every algorithm you'll ever see has the same basic structure. It's got three parts. First, what information does it need to even start? We call those the inputs. Second, what does it actually do with that information? All the calculations and actions, those are the processes. And finally, what's the answer it gives you at the end? That's the output. It's that simple. Input, process, output. Remember that.
All right, let's talk about flowcharts. These are awesome because they let you literally see the logic of your algorithm. You absolutely need to know the main shapes. The rounded ones, the ovals, are for the start and the end. The slanted box, the parallelogram, that's for any time you're getting an input or showing an output. A plain old rectangle is for a process, like doing a bit of math, and the most important one, the diamond. That's for a decision. It's where your program asks a yes or no question and goes one of two ways. Super important.
Okay, next up is pseudocode. And honestly, this is your best friend when you're planning. Think about it. Before you get bogged down in all the fussy rules of Python or whatever language you're using, all the commas and brackets, pseudocode lets you just sketch out your plan in a kind of structured English. It's the perfect middle step. It lets you get your logic right first before you even think about writing actual code.
So you've got your flowchart, you've written some pseudocode, but how do you know if your brilliant plan actually works? Well, that's where a trace table comes in. This is where you literally pretend to be the computer. You go through your algorithm line by line, and you write down exactly what happens to each of your variables at every single step. Trust me, it is the best way to spot mistakes and fix the logic in your algorithm before it's too late.
Right, time to get into the classics. The exam spec says you have to know a few standard algorithms. We're talking about the famous ones, the ones for searching for stuff in a list, and for sorting a list into order. Let's do it.
When it comes to searching, there are two you've got to know. First up is the linear search. This is the simple but slow way. It's like looking for a specific book on a messy shelf by starting at one end and checking every single book until you find it. It'll get the job done, but it can take forever. Then you've got the binary search. This one is clever. It's super fast because it keeps splitting the list in half. It jumps to the middle and asks, is the thing I'm looking for bigger or smaller? And bam, it throws away half the list. But, and this is a huge but, it only works if the list is already sorted.
So that begs the question, right? How do you get a list sorted in the first place so you can use something speedy, like a binary search? Well, your exam spec wants you to know about 3 ways to do it: the bubble sort, the merge sort, and the insertion sort. They all have a different way of taking a jumbled up list and putting it into perfect order. Okay, everybody, deep breath. I want you to really listen to this next part because it is probably the best news you'll hear all day. This is a direct quote from the official OCR specification. It says, you are not required to remember the code, pseudocode, or exam reference language for these algorithms. Let that sink in. I'll say it again. You do not have to memorize the code for bubble, merge, or insertion sort. Huge, right?
So, if you don't need to memorize the code, you're probably wondering, what do I need to know? Well, it comes down to 3 key skills. First, you need to understand the main steps of how each one works, like what's the big idea behind a bubble sort. Second, you need to be able to actually do it. If they give you a list of numbers, could you perform the sort by hand on paper? And third, if they show you a piece of code, you need to be able to look at it and say, I see what's happening here. That's an insertion sort. It's all about understanding and applying, not just memorizing.
All right, we're on the home stretch. We've talked about how to think, the tools you'll use, and the classic algorithms you need to know. So let's bring it all together. How do we make sure all this knowledge turns into maximum marks when you're sat in that exam hall? Look, if you take away just one thing from this whole explainer, make it this. Everything we've talked about boils down to 3 core skills. 1, think like a coder. Use abstraction and decomposition. 2, design your solution. Use flowcharts and pseudocode to plan it out. And 3, test your logic. Use trace tables to hunt down and squash any bugs. Think, design, test. That's the secret sauce.
And why should you care so much about all this? Here's why. 50%. Paper 2, the one that's all about computational thinking, algorithms, and programming, it's worth half of your entire GCSE grade. No, seriously, half. So getting good at this stuff isn't just a nice idea, it is absolutely fundamentally crucial to getting the grade you want.
And there we have it. That's your crash course on algorithms for the J277 spec. But remember, this stuff isn't just about passing an exam. These are genuinely powerful ways of thinking that will help you solve all sorts of problems in the real world. So good luck with all your revision. Now, what problem are you going to solve first?